Day 12, Part 1. Your ferry made decent progress toward the island, but the storm came in faster than anyone expected. The ferry needs to take evasive actions. Evasive actions! I needed to have more exclamation there. Unfortunately, the ship's navigation computer seems to be malfunctioning. Rather than giving a route directly to safety, it produced extremely circuitous instructions. When the captain uses the PA system to ask if anyone can help, you quickly volunteer. The navigation instructions, which are your puzzle input, consists of a sequence of single character actions paired with integer input values. After staring at them for a few minutes, you work out what they probably mean. So it looks like we have a collection here of absolute and relative directions. So N is north, south, east, west. And those are the absolutes, and then LRF are the relative movements. The ship starts by facing east. Only the L and R actions change the direction the ship is facing. So if the ship is facing east and the next instruction is N10, the ship would move north 10 units, but would still be facing east. Okay, these instructions would be handled as follows. F10 would move the ship 10 units east because the ship starts by facing east. East 10, north 0. N3 would move the ship 3 units north to east 10, north 3. F7 would move the ship another 7 units east because the ship is still facing east. That's right, yeah, so it's going forward in that direction. And then R90 would cause the ship to turn right by 90 degrees and face south. It would remain at east 17, north 3. F11 would move the ship 11 units south, east 17, north south, or south 8. At the end of these instructions, the ship's Manhattan distance, the sum of its absolute values of its east-west position and its north-south position, is 17 plus 8 is 25. So I'm thinking we could model this with, first of all, like we'll have a class for the instruction. You'll have a direction and a value. And we also need to keep track of the ship. The ship will have basically just a direction that it's facing and a position. And the position could be XY coordinates. XY could be east-west, and then the Y coordinates, or X could be east-west, and then Y could be up-down. I don't think we need to keep track of, it's really just, these are Cartesian coordinates here. And then we just take the absolute value of the X, add it to the Y to get the Manhattan distance. So I think this is not too bad. First, let's just parse the input as we usually do. I'm going to make a class, I'm just going to call this day 12 test. And then we're going to use our test util. Parse input. I already created a class, or a text file to have that input. So we're going to parse the input. We're going to pass in this. We're going to pass in day 12. And then our mapper, we can actually put this on our mapper per line. We're going to want to create a navigation instruction class. And this is going to be a data class. It's the Kotlin convention. And then this is going to be a val direction. And I'm going to make this, I'm just going to make this an enum to be cleaner. nav direction, and then we're going to have N, S, E, W, L, R, F. The direction is going to be a nav direction, and the value is going to be an int. I'm going to create another class for now, just for the ship. This ship is going to have a it's going to have a position x, y, val y. I'm going to just pass these in first. Y is an int. I think I might actually not initialize those. I'll just have var x is an int, and this is going to be private, and that's going to be 0. And then y is an int, it's going to be 0. And then I'm going to have a function to move. And that's going to take a nav instruction. And then the ship is also going to have to know its direction. I know it's a little bit redundant, but I might have a separate EM class for a ship direction. Although maybe for now I will reuse this direction. Var direction is this nav direction. Oops. And then this is going to be east. No, we don't want to do that. There we go. And then I think I'm going to make these into these like private. Or I think we really just want the distance. I'm going to make a distance is going to be an int, and then get is going to be absolute value of x plus absolute value of y. Just going to be our Manhattan distance here. Okay, so then the navigation instruction. Now we basically just parse this into I'm going to factor this. I'm going to just go ahead and factor this into a separate private fun. Take a file name, and then this is going to return a list of nav instructions. And then we're going to parse it by this file name here. And now we have a string, and we just want to have a val direction is it's just the first character here. Value of this it.substring 0, 1. I think I'm just going to go ahead and just return a nav instruction of this, comma, start index, and then it.length .toInt, and that's it. So that should give us our nav instructions. Instructions.length or .size should be, we're expecting just 5 instructions this time. And let's see how it worked. Okay, so we get FNFRF, FNFRF, 10, 3, 7, 90, and 11. Okay. Oh, so this actually, I misinterpreted this. This is to turn. You have to turn by that number of degrees. Okay. That changes things. We still do have to keep track of the direction the ship is facing. Let's take a glance at this input here. Looks like these are all divisible by 90, so we're not going to be having the ship go on a diagonal or anything. I think I am going to go, I'm going to make a separate, I think we need to keep track of the ship. The ship direction is going to be different from this nav direction. We need to have a distinct enum to determine, like, it can only be 4 different values, right? Where this direction can be several different kinds. I'm gonna name this nav action. Nav action. Unselect all. And then I'm gonna have a ship direction enum. And then that's going to be north, east, south, west. And that's going to represent the direction the ship is facing, just to distinguish that from the action type. So this is going to be ship direction, and that's going to be east at first. We can parameterize that too. So I'm going to have that initial direction. The ship direction is the initial direction. This makes this redundant. Okay. Now we need to figure out how do we handle a rotation? Like, how do we handle, let's say, I'm going to have a private function to turn, and then that's going to take this nav instruction here. And I'm actually going to make this more generic. I'm going to have handle instruction, and I'm going to have one for move, one for turn. And I might distinguish between the types of instructions here. Although I think the ship should be responsible for deciding how it wants to handle the instruction. I'm going to say should turn. I'm going to make a private fun. Should turn, and then given the instruction type, really, that is going to be a Boolean. We're going to say oh, I see. So I think I'm going to make action in list of these turn actions here. Nav action L, nav action R. There we go. Okay. Now let's just handle the turn. I think I'm actually going to make this a private parameter, and then that way I can write a couple tests around, like, how does the ship handle an instruction that's to turn 90 versus 180, 360, whatever. That is another way we could do it. We could mod mod whatever the value is by 360, and then that way there's only one of 4 values. Yeah. I'm going to have a public getter for direction here. So that way an outside class can figure out what direction the ship is facing without actually mutating the value of it. So we're going to handle this instruction if should turn, and then the instruction dot action, or dot, I'm going to change this to action. There we go. If should turn, and then turn. And I think what I'm going to do is have we need some kind of a map of east. So the things that come after east, so east would be, if you turn to the right, it would be south, and then west, north. So we need to have some orientation of what directions follow what. We could use the ordinal values, I think, of these ship directions. Yeah, you could probably just go off the ordinals of these. I don't know if there's an easy way to just get if I'm at north and I want to get ship direction at position. Oh, no, you should not use the ordinal. Okay. I am going to store this separately in a list. And I'm going to actually make this static, so I'm going to create a companion object. So we're going to do a list of, doesn't matter what order these are in. And this is basically, so if I have turn right 90 and we are at east, I can take the value of or I can take the index of that value and then mod it, and then it'll give me mod it with the number of turns. So we either go forward or backward in this list, and then it should give us the direction that we should be facing at that point. So we can write some tests around this. So north, east, south, west. And then I'm just going to static import these. There we go. And now what we want to do is take the val direction is instruction.action when direction. I'm gonna just do if direction is R, and then else, because there's only 2 possibilities for this direction. So now we want to take we we know the current direction that the ship is facing. And then I'm going to say num turns equals instruction dot value. And then first we want to mod it by 360. So that way if there's multiple turns, we want to, like the end result, we want to count like any like 100 or any like full turns, we just ignore those. We really can care about the direction that you end up facing afterwards. So we're going to mod that value by 360. And then we're going to divide that by 90 because those are going to be the increments of these directions. So like an increment of 90 is going to turn you east, south, west here. So that'll give us the total number of turns. So if the direction is right, that means to turn clockwise. So we want to move forward. This ship directions is listed in order of a clockwise movement. So we want to move up in this array. So we also want to do, we're going to need to mod whatever value we get for here. I hope I'm articulating that okay. So we want to have the number of turns. We want to go ship direct. First we need to get the index of the current, index of direction. That'll tell us where we're at now. And then we want to set direction to ship directions. And so I'm going to have this index up here. So here's the current index. Ship directions index plus num turns. And then we want to mod that. Mod that by ship directions dot size. So that should give us, like, let's say you're at, oh, hang on, dot get, and then we can replace that. So like, let's say you're at east and you're turning 270 degrees. So that would result in, like, mod 360, that would still be 270 divided by 90, that's 3 turns. And then you have this index of 1 here. Well, 1 plus 2, 3, 4, that's going to be an overflow. And so we want to mod it so the remainder is going to be 0, which is going to be north here. Is that right? Yeah, so east 270 degrees would be north. And then now the tricky part is, how do we handle the left turn, which is the counterclockwise? So this is going to be, let's do a, we want to do index minus the number of turns, and then we want to subtract, I think what we want to do is ship direction stat size minus this. Index minus num turns. Is that going to work? So like, let's say you're at east, right? And you're turning around 180 degrees. That's going to be 2 turns. So the index is going to be 1 minus 2. So you're going to end up at -1. I think we want to add this. Is that right? The problem is, like, let's say you're at west and you turn left 90. So this, I think we might still have to handle some overflow here. So like, let's say you're at west and you have a single turn -1. So west is at index 3. 3 minus 1 is going to be 2. This is going to be 4 minus 2. That's going to work. Let's say you're north and you have a direction of -1. So that's going to be -1. And then shift directions outside is minus. That's going to be minus -1. So I don't know that that works. We need some kind of like reverse mod. So if you go negative, you actually want to be, if it's a negative value, I think we just have to have some kind of conditional. Like if there's a negative value, then you want to just subtract off the shift directions that size to get your current index. Otherwise, you leave it. So we're essentially like making our own mod. Yeah, I know in Python, if you specify the negative index of an array, it'll give you the index from the right, but Java doesn't, or Kotlin doesn't have that. I don't think. Yeah, I don't think that that is going to work. So we'll just do new index. Is index minus num turns. To do this. I'm going to have a result. I'm going to actually call this difference. So new index, val new index equals if difference is less than 0. We want to do shift directions dot size minus difference, else difference, and then we're going to have this new index here. Okay. Oh yeah, that works. Okay, so then direction equals this. If it's right, then that's easy. Otherwise, then we do this. So what I want to do is now I just want to write some tests around this. So val ship equals ship, and then we're just going to keep this the default of east. Val turn left. Actually, I'm going to do a couple things. I'm going to do ship dot handle nav instruction, and then we're going to say L and then 90, and I'm just going to, just to be safe here, I'm going to pass in this east, and I'm going to just import that. So we want to go L90 ship dot position or dot direction should be, if we're turning left 90 from east, we're going east, we want to be north now. And then if we go from there, if we go right, 180 should be south. Let's try that. And then let's do some with, you know, like 450 or something. Something over 360. So if we do 360, should still be south, right? And then let's try. Yeah, let's try like 450. So we're turning right 450, which is really turning right 90, and then that should be going clockwise, so that should be west. Let's try that out. Seems like it's not parsing some of this correctly. Did I forget a bracket somewhere? Oh, there we go. Okay. Let's run that. Okay, so it seems like turning is working okay. Let's try a L move. Let's try left 450 from here. And then that should get us back to south, right? I think the left movement I'm the most concerned about. It's like Zoolander, you can't turn left. Okay, so it's still working. Alright, so I'm pretty confident in the ship turning. So now we just have to normalize on the Cartesian coordinates. So we have the ship X and Y. If the ship is facing south and it moves forward, we want to have whatever value that is to be negative. So now we have the like rotation stuff all handled. Now let's handle. I think we do need to have a kind of a special case for this forward. So it's going to go forward in whatever direction it is. So let's say ship moves in X, Y direction, positive Y is north, positive X is, let's say, east. So then, yeah, we'll just standardize on that stuff. I think I'm going to write a when case. This is like a Kotlin switch case statement. So I'm going to say when instruction action should turn, and then that's going to be it. And then we're going to turn. I don't know why that's not handling, because this should be a should give me a variable it that I can use here. Oh, maybe not. Not in that case. Should turn. Maybe not. I don't think this will work. I'm going to go back to, I'm going to revert to what it was before. If should turn instruction.action, turn. Else if we're gonna handle that we're going to handle that forward case. I'm going to have a move forward, and I think that might actually delegate to the move method, because move is going to take a direction and a value, but move forward needs to account for the current direction of the ship. This is going to be a private function to move, and then that's going to take a ship direction, or a, let's say direction, ship direction, and then a value, which is an int. And then I'm just going to use this to delegate to move direction, and then the current direction, and then value. And then what this has to do, this will be pretty easy. This just has to go delegate to move forward, and then the instruction.value is the amount to move forward. And then this just accounts for the ship's current direction. This else case is going to have to normalize these values to oh, okay, that's even cleaner. That's what I was trying to do in the first place. Else, I'm going to have a map of private val, action to direction, and that's going to be a map of, and that's going to just normalize these action. This is just going to convert a nav action dot e to east, and then we can normalize these directions. So I'm just going to make several of these. Nav action w to this ship direction of west, and just to be consistent here, east, north, and to north, east, and then this is going to be south and west. Okay. And then I will delegate move, and then this is going to be action to direction of this instruction.action, and then the value here. Some of this might look a little bit redundant, but I do want to normalize on, I just want to normalize on the ship direction so that we can use that, because we need like a limited set of directions that we can use for determining the direction the ship should use. So now we need to handle this move. And then I'm just gonna make a when direction north, we're going to go y plus value. East, we're gonna have x plus value. South is gonna be y minus value, and then west is going to be the x minus value. And I think that should do it. Let's try it out. So we're going to parse the input. This file name is day12.txt, and then we're just going to go to for each, and then I do have my ship.handle, and then we have the instruction, and then ship.distance should be 25. And let's just confirm that the x and y values are the 17 and 8 here. That didn't work. Whatever just happened, it still thinks it's at 0, 0, and it thinks that it's going south. So what happened? We make some stupid, silly mistake here. So let's check out what happened. So this says forward 10, right? So we're expecting it to move forward, and it's going east. Oh, that's why. I didn't actually set the y value. I'm going to say plus equals x plus equals y minus equals x minus equals. So I wasn't actually mutating any of these parameters. So let's try that again. Now these are actually mutating. This ship is now at 17 and negative 8, but when it computes this distance, it's going to be taking the absolute value. So that passes. Now let's try the full input, because I'm pretty confident in it at this point. Test input, and then part 1 input. And I'm just going to print ln that ship.distance here. And I'm going to go day 12. I think I saved day 12 full. Nope. So I need to make a day 12-full.txt. Get your puzzle input here. And part 1 input, day 12-full. What do we got? Didn't like it. Null pointer exception. Did it come across some instruction that it didn't understand? I'm going to have, I think I could turn on exception breakpoints. Oh, I think it's down in my, is it under breakpoints here? It's been forever since I did this. IntelliJ exception breakpoints. Command F8. That's what, oh no, that's to enable them. View breakpoints in the debug window. Okay, that's right. I want to have Java exception breakpoints. I think that's the same as a Kotlin exception breakpoint because it is a null pointer exception. So let's try that, see where that threw. I'm not worried about that. So S1 was it had a problem with S1. Sure enough, yeah, I had a typo here. So I just need to have S to south. Okay, now we should be able to run it, and it'll have no trouble, in theory. Index 5 out of bounds for length 4. So this was a left turn that it had trouble with. I'm going to set a breakpoint here. I want to see how it got this new index of 5. New index is 5. Done. I don't want these, whatever. Difference is -1. So this was a left turn of 90. And the ship, what direction was it facing? The ship was facing north. Okay. And so we would expect that a left turn of 90 would make it face west, right? So here's the ship directions. Right, so this is -1. So we actually want to do ship directions at size. That's why. So this size is actually not the... We want the final... Difference. So size, hang on a second. So size is going to be 4, right? Oh, if it's less than 0, we want plus the difference. Yeah. Yeah, so that was just an edge case that we ran into. Okay, let's try that again. .439 is the Manhattan distance that we got, so let's try that out. That's the right answer. All right, I think I'm going to stop the video here and make a separate one for part 2. So I will see you in the next one.